Number 17 right here. It asks for the linear approximation, and it asks you to find the error. Now, the linear approximation here, it means it just wants to know the change. So what is the change from this guy to this guy? Okay. Now, there's a couple things related to linear approximation that we need to make sure that we are aware of and we are identifying. One is that we know that the change in f, the approximate change in f, which is known as linear approximation, is going to be f prime of a times delta of x. So we need to know what f prime is, so we can plug in a to it. We need to know what f is, so we can find f prime. We also need to know what delta x is. And then finally, oh yeah, last one, we have to know what a is. So look at all these things we have to know right here. Okay, so let's look at what we're given right here. So we got to come up with a function for this. Then we got to see the change in x. And what is the a? A is supposed to be the number that's nice, the one that you can do in your head very simply. Okay, so what is our function? Anybody want to take a guess? Yeah?
Square root of x.
Square root of x, radical x, okay. So I go over here, and this one's actually not too difficult to predict. There's some other ones, like this guy down here, he's pretty, well, that one's not that bad. This one's, wait, which one do we do it? This one's weird to predict. But anyways, so this is f. What's our f prime? That would be negative 1/2 x to the negative 3 over 2. Okay, if you want to find the derivative of that, I would just recommend changing the radical into a 1/2 power and then find the derivative. Okay, and then the change in x. Okay, so Phoebe, what is the change in x? Going from 25 to 6? Yeah, it's just 1. So that one's not that bad. And but what is the a?
Isn't it?
What's the a? Is the a going to be the 26 or going to be the 25?
25.
Yeah, 25. You're right, that shouldn't be a negative. I don't know why I said that. So this would not be this. Oh man, I totally messed up that derivative.
It should be 1 over.
Mr. Patey, don't do derivatives in your head. All right, sorry.
X to the negative.
Negative 1/2, like that.
There you go.
Sorry. That's why there was a low rumble when I did that. I do something together. Oh, okay. So, anyways, so now we come back up here. Our linear approximation. This is what we're trying to find. So let's plug in stuff. So we have f prime right here, and we're gonna plug in a. What's my a? Oh yeah, it's 25. So we have f prime of 25, and then we know what our delta x is, which is just 1. So that's just gonna go away. We really just need to find f prime of 25. Sweet. So we plug in 25 to this, so it's going to be 1/2 times 25, and we're trying to find a negative 1/2 power of that. Now that would mean that we have a 1/2 right here, and we're multiplying it by 1 over 25 raised to the 1/2, but that's the same as a square root, which is the same as 5, and so we multiply, we get 1 over 10. Now that's the approximate. That's the approximate linear approximation. Okay, you asked me what did I just do, but let's be more specific. What question are you asking me? Asking me like how I used this formula right here to plug in stuff? Alright, so now you got the formula there and you know what I'm talking about. Okay, so this is just the linear approximation. That's the first part of the directions. The second part says find the error using a calculator. Now in order to find the error, we need to know what this actually does equal. So you got to take this and plug it into the calculator. So then what does this actually equal? So get your calculator, go radical 26 and subtract from that to radical 25, which is just 5. Okay, so when you guys did that, you guys got 0.00 0.000093. 4 zeros?
Yeah.
Is that right?
That doesn't seem right.
Can you guys double check that?
Yeah. I got 0.099.
Okay, that actually sounds better.
Check the back of the book. Maybe the book's long.
Okay, I'm going to do it. Alright, you gave me the answer. You're not paying attention. Alright, it's 0.09902. That's what I wanted. When you plug this in, this is what you get.
Let's go, Arsen.
Okay.
Good job, Arsen.
Okay, yeah, he was saying the error. Now let's see how we find the error. Let me finish, please. Okay, now if you're trying to find the error, what you got to do is you got to take the actual number and subtract the estimate. So you can see how far you're off. The error is just the difference between the two. And so when you do that, then you get Arsen's answer.
Minus.
Double check it, please.
That's right.
Minus
Is it
parentheses
936?
1 divided by
Whatever.
10.
So this is error. Does it want the error percent? No.
Yeah, it's 9386.
But if you wanted to 86, that's an 8. Okay, if you wanted the percent,
The book says 80.
okay, if you, like I was trying to say, if we're trying to find the error percent, what you gotta do is take this number, divide it by the actual number, which is 0.09902, and then multiply this by 100. That'll give you the error percent. But this just asks for the error number.
So error